hoping you could just tell me the solutions and I would not have to do this with you. What are we going to do first? Take this, not square them both. Square root of them both, yeah. We're going to take the square root of our 3x plus 6. Oopsie, that'd be good if I could put the addition sign in there also. 3x plus 6 squared, and we're going to take the square root of 9. The square root of 3x plus 6 squared is what? 3x plus 6. The square root of 9 is? Positive and negative 3. So there are going to be two solutions because we're going to have to set up two problems here. 3x plus 6 equal to positive 3 and 3x plus 6 equal to negative 3. And I'm not convinced we should get opposites. I think we better actually do this. If this is not what you did, you need to get it done. And not be presumptuous that it should just turn out so nicely to be opposites. I get x equals negative 1 and x equals negative 3. So there's no shortcut to this. When we end up with not just x by itself on one side, we can't just say, oh, okay, well, let's solve one of them and say the other one is the opposite of it. So we can't say the answer is negative 1 and positive 1. We could have if x would have been by itself, or x squared would have been by itself even, but that's not going to happen in a problem like this. So don't take shortcuts you really can't take. Okay, so what's going to happen today is when we're solving using the square root method, no matter what you try, you're not going to be able to create perfect squares on both sides. And so then that's going to complicate it because you're like, well then I can't take the square root because it's not a perfect square. That's what you're going to feel like you can't do. And then you're going to say there's no solution. That's not true. We can take the square root of numbers that are not perfect squares. Would you take the, give me an example of a non-perfect square. 7. Would you take the square root of 7 right now in your calculators, please? Because this is a good point. If you don't know how to take the square root of something in your calculator, you better learn. And then I want you to round that to the nearest hundredth. And I want you to round the square root of 7 to the nearest hundredth. If you can't get your calculator to cooperate with you, get your hand up. Maybe somebody in this room can help you out. Well, I don't have my calculator. It's over there. I don't want to walk over to it. But I at least know this much. I know that 7 lies between two perfect squares, and the two perfect squares that lies between are 4 and 9. So I know right now that, you know, if I don't have a reasonable answer unless I get 2 point something. Because the square root of 4 is 2, the square root of 9 on the other side is 3. So the square root of 7 has to be somewhere between 2 and 3. So the square root of 7 is approximately 2 point, rounded to the nearest hundredth. 7, that's tenths. 2 and 7 tenths, that's that rounded to the nearest hundredth. You're going to make me want to work my calculator after all. Seriously? Okay, fine. Second, x squared 7 2 points, okay, I guess I'll just write down what my calculator says, and you can tell me if yours kind of looks the same. And maybe yours won't take it out quite as many units as mine does, because I just have this fancy graphic that likes to give. So, do you agree? At least up to a point? Okay. So, tell me, what digit is in the hundredths place right now? 4. Where did we fail you guys in the math system? Where did we fail you? That you cannot all just proudly announce that in the hundredths place is the 4. But we can't be happy to say that it's 2 64/100ths until we look in the thousandths place to see if that's big enough to make it 65/100ths. Is it? Is 5 thousandths big enough to make this 65/100ths? Yes. So in other words, it's closer to 640 or 65 than it is to 60. When we round up, it's going up to 5, not 64. And there's no. By the way, I'm a little curious how, even if you rounded it to the wrong place, how this became 2.7. How does 6 with a 4 behind it become 7? Good luck getting the bank to round up like that. I don't think they're going to do it. Or on your paycheck someday. You just say to your employer, well, seriously, are you kidding me? 2.64 can't be 2.7? What's wrong with you? They're going to be like, well, I don't know, but you're not getting it. So this we would say is approximately 2 65/100. We're going to move on eventually here. We're going to give you another chance. Give me another non-perfect square. 8. Okay, would you find the square root of 8 rounded to the nearest hundredth, please? And you might have to pick me up off the floor if you cannot give me the correct answer. When you think you have it, come up and put it on the board somewhere. Go, make it happen. And no, just taking somebody else's answer, you go with what you say it is, because you might steal the answer from somebody who doesn't really have it right. I'm still breathing there, we all know. There's a problem with that up there. Did anybody see it?
No, not at all.
No? Really? I can't lay on the floor very long, it makes me sick. There's nothing wrong with there? Looks good to me. I'm gonna have to teach another 100 years. Because students don't get how to use even their calculators. They beg to use them and then they can't even use them. We're not going to make fun of whose it is, but was there a little transposing of numbers going on there? The good news is, without that one, you all rounded correctly. Woohoo! Good job. Okay, let's get to work here. Sometimes solutions need to be approximated when we are solving. You don't get to say no solution. You're going to round to the nearest hundredth. You just had practice, okay? So, number 1, 6x squared equals 36. That would be very tempting to say, I could just go right to taking the square root of both sides because there happens to be a perfect square up there. What is it? 6? 36. Whoa. Ronnie wants 6 to be a perfect square, is it? Go ahead. Never mind, okay. How about 36? Is it a perfect square? It is, but wouldn't we need both sides to be perfect squares? To be able to go right to square root in here? So today I'm giving you, they aren't both perfect squares, you have to go to this step which says divide both sides by that 6 to get the x squared alone first. So we're getting the x squared alone because there weren't both of those numbers were not perfect squares. Well, you're going to kind of feel like we just ruined it because 36 was a perfect square, and now when we divide it by 6, it becomes 6. Positive or negative 6, or have we done a square root yet? No, we don't need to do that yet. Be careful, we're just getting x squared alone right now. So x squared equals 6. Well, way to ruin it. Now it's not a perfect square either. Well, that's what's going to happen. We're going to square root x squared because we need x. We're going to square root 6 because if we do it to the x squared, we got to do it to the other side. X is what we get out on the left side, and since, Devontae, did you prove to yourself that 6 is not a perfect square, by the way? Since we are going to have to round, we're going to use the approximately equal to symbol, the squiggly one. And there's still a positive and a negative square root of 6, even though we're going to have to approximate it, it's still a positive and a negative. Round it to the nearest hundredth. Go ahead and put it on your paper what you believe it is. And if you don't agree with me, go revisit your calculator. See if you can agree with me now or you still need to change my mind. Do we agree? So I'm not going to let you be haphazard about rounding. For some reason, I think that's been like not a big deal in your math lives. It's like, well, get close, whatever. No, we should know how to round. That's a skill in itself. Okay, what do you think would be the first thing we would do in number 2? Considering what I just said at the beginning of class. Make a positive, add 8x squared to both sides. Okay, let's add 8x squared to both sides so that we will have a positive a value. So now we're going to have 144 on one side, 8x squared on the other side. How do you feel about 144? Is it a perfect square? Yes. Is 8 a perfect square? I think we just decided that a while ago that it wasn't, right? So what are we going to do next? Not subtract 8. Divide both sides by 8. How many 8s can you take out of 144? 18, exactly 18. So now we have 18 equal to x squared. Is 18 a perfect square? No. So, you know, we're kind of at that point now that we say, you know what, I already know that, oh, I don't have to do that yet. I got to take the square root of both sides here. The square root of 18 equal to the square root of x squared. 18 is not a perfect square, so I already know I'm going to be using the approximately equal to symbol, showing that I had to round. And again, I'm going to give you another chance to show me you know what you're doing. Round it to the nearest hundredth. Or and 24 hundredths. Okay. Enough? Thank you, Noah. Plus or minus. Don't forget that. Positive and a negative. A negative 4 and 24 hundredths times a negative 4 and 24 hundredths should get us back to about 18. Would you try that on your calculator, please? Would you take either the positive form or the negative form of 4 and 24 hundredths times itself and see if this gets you back to exactly 18? What does it get you to? 17 point something, right? Should it get you exactly back? No, because we rounded, yeah, it's not a perfect questions on the front side? Okay, let's go see what's happening on the back here. Maybe should be our move we could make in this one. Yeah, we can't even talk about perfect squares yet until we get the x squared term by itself. So the first thing we're going to do is we're going to subtract 11 from both sides. Now you can stop and ask yourself, are these numbers perfect squares? Is 2 a perfect square? 2 a perfect square? It's a very nice looking number. It's an even number, but it's not a perfect square. So if 2 isn't, we don't even have to care about whether 110 is. We're going to do what next? Divide both sides by 2. Divide, not subtract. And then we're going to have x squared equal to 55. 55 a perfect square? Okay, square root of x squared, square root of 55. X is approximately equal to positive or negative, just, you know what, after you make your approximate equals sign, you better just automatically do that so you don't forget it. And then, did I hear 7 and 42 hundredths? Okay. So, we need the x squared term to be by itself. So what do you do to make that happen? First of all, you always want to make sure that you do it so that the a value is going to at least be positive. Because then, if the other side turns out to be a negative, then you can, when you try to take the square root of both sides, then you can finally say, you know what, this is a no solution because I can't take the square root of a negative number. But you can't say that without a being positive, okay? Okay, number 4, Mr. Banks is building a retaining wall along one of the sides of his rectangular garden. What's a retaining wall? What's that mean? It retains water. Okay, so is it like something that's built up off the ground? Yeah, it's a big old wall. And retain, yes, it's built to retain something, or either retain the ground behind it, or maybe to retain water, or whatever. So along one of the sides of his, on the long side of his rectangular garden, I've already drawn the picture here for us. There's his garden. His retaining wall is along the top edge of the picture there. It says the garden is twice as long as it is wide. It has an area of 578 square feet. What will be the length of the retaining wall? So how do we find the area of a rectangle? I want to talk about this, and we should know how to find the area of a rectangle by the time we're 10th graders. Length times width. It's a scary thing. Capital A for area equals little l times little w, length times width. Well, did they give us the length? Did they give us the length? No. Did they give us the width? No. What did they tell us? They told us the area. Okay, well, let's fill that in over here. Apparently, I think that's going to be important information. That the area is 578. What else do we need to know? It's twice as long as it is wide. So it's kind of like we're going to, instead of calling them an L and W, we're going to give them some new names here. So what could we call this length that is twice as long as that width? Kind of sounds like the width is in charge here at the moment, isn't it? So, pardon? Yeah, let's call the width X, because it says, you know what? I know I'm X, and length you are twice me. So what would the length be? No, we don't introduce a new variable. We don't know how to solve those darn equations with 2 variables in yet, unless we know how to unless we can set up a system of equations. I want us to name the length in terms of x, because it's said it is twice as long as the width. Twice, it would be x squared if x was 2. 2x, there you go. It's twice as long as the width. So the width of the rectangle is x, the length of the rectangle is 2x because it's twice the width. The area is 578. We are ready to sub into our area formula. 578 for area, 2x for L, x for W. Go ahead and solve that because you know how. Go ahead and solve that because you know how. Being equal to, no squiggly this time, because 289 is a perfect square, isn't it? So x is equal to a positive or a negative 17. Well, we just solved for the what? X, the width. So this tells us what the width is. Is that what the question was? What will the length? Oh yeah, I didn't ask for the width, I asked for the length. So first of all, the first thing we're going to come over here and we're going to say can't have negative width. So even though there are 2 square roots for 289, that negative 17 is worthless. You can't have a negative 17 for a width. So we're going to say that our width, our x, is only 17. Well, to get the length, what do we have to do? Remember, our length is 2x, so we have to take 2 times 17. The final answer is 34, and since the area was measured in square feet, what would this one's measure be measured in? Square feet? No. Just feet. How do you measure a length in square feet? How do you measure a length in cubic feet? Why is there all kinds of weird things? The length is feet, the width is feet, 34-foot length, 17-foot width. Would you do that on your calculators? Would you see a 17 times 34? First of all, it's 578. Then we're good. And then, I don't think your calculator can do this. When you take feet times feet, what do you get? Feet squared, also known as square feet. So this is the length of this rectangle is 34 feet.